Hello, welcome to High Peak Education. Have you ever wondered what it takes to understand the weather at your city, to understand what the meteorological variables are that affect you? Well, that's what we're going to address in today's video by doing this meteorology problem and also discussing various things that relate to finding weather data. So we were given this map which says MSL. So MSL is mean sea level. So this is mean sea level analysis, and HPA is hectopascals. So hectopascals are hundreds of pascals. Now recall, pascals are the unit, the SI unit of atmospheric pressure. Notice this map is also for 0 UTC on April 27th. So 0 UTC means midnight in Greenwich. That's England. So over here in the Middle East, we are a couple time zones to the east of Greenwich, several time zones. So it's later than midnight, so it's probably early morning. Okay? But we're going to take a look at various meteorological variables here in the Middle East. So here you see the Arabian Peninsula and the Persian Gulf, and then we also see the Strait of Hormuz and all this. There's a lot of oil that comes out of this region of the world. What we're interested in here is point A and point B. Now point A looks like it's in northwestern Saudi Arabia, and point B is in Qatar, or maybe more properly pronounced Qatar. So we have 6 things that we want to know. We want to know what kind of a pressure system that the area is under the influence of. We want to know what the atmospheric pressure is, number 2. We want to know what the true wind direction and speed is. And then we want to know the cloud cover in eighths. So in eighths meaning a portion up to 8/8 would be fully cloud cover. 0 out of 8 would be purely clear skies, purely sunny skies. And then precipitation, and then the temperature approximate in degrees Celsius. Well, just looking at these maps, we can get the influence of the pressure system. Notice that there's a pretty large high pressure system near each of these stations. So these high pressure systems, we're going to say for number 1 that they're under high pressure for both. That is to say, this low pressure system is not extremely low. It's not in the 900s of hectopascals. Also, it doesn't have closed isobar contours, and basically it's just not a very strong low pressure system. This is probably a thermal low pressure system. Thermal low meaning generated from just an enormous amount of heat from the Arabian desert. But these high pressures are dominating north central Saudi Arabia and Qatar. So it looks like the pressure in Qatar, let's start with B, looks like that's about 1008 hectopascals. So 1008 hectopascals. This is point B. And then point A, we want this contour. So that's about 1010. So 1010 hectopascals. All right, so that takes care of question number 2. Now how about question number 3? We want to know the true wind direction and speed. So this is where we need different maps. From these maps, we note that we're in the northern hemisphere. So if we stand with the wind at our back, low pressure should be on our left and high pressure should be on our right. So the wind direction somewhat generally should be maybe somewhat this way or somewhat this way. It's hard to tell exactly. But I guess what I'm getting at is that's the sort of the general wind direction we expect. because low pressure should be on our left and high pressure should be on our right. But let's look for some more information on that. So I have a map here from Plymouth State University. So Plymouth State University is a very nice weather center where you can get archived weather data from in the United States and around the world. Now, here's the main URL. I'd recommend you check that out, and you can look at the archive data on some of the links there. What I have plotted here is the surface wind speed, and I've got that plotted. Let's see, and that's in knots. So knots are going to be nautical miles per hour. Okay? Then we are at the same time, so this is important. I had to make sure the timestamp was the same time. Notice that these L's and H's are not low and high pressures. They're just low values and high values for wind speed. So the lowest is negative 2.11, whatever that really means, and the highest is 30 knots. Okay, so let's try to toggle back and forth to look at our two locations. So our location should be just east of the tip of the Sinai Peninsula here in northwest Saudi Arabia. So I'm going to say if this is the tip of the Sinai Peninsula, it's somewhere near here, approximately. So I'm just making a guess. Okay. And looks like point B should be on the southeast coast of the peninsula of Qatar. Again, some people would call that Qatar, but that would be right around here, approximately. Again, I'm doing my best. So for this point and this point, we want to know the approximate wind speed. Well, the wind speed here looks like it's somewhere between 1.64 and 4 knots. So let's take sort of an average, and let's also favor the 1.64. So let's say at point A, it's about 2 knots. So 2 nautical miles per hour. And then it looks like that here's 15.9 knots. Here's a contour for 12 knots. And then we also have the blue contour, which gets us out of the light blue into the darker blue. That would be 8 knots. So this is probably going to be somewhere between 12 and 8. So it's probably about 10 knots. So about 10 knots. Okay, hopefully you see how to read that. This point is about 10 knots, because this is the 12 contour, and then this dark blue, which you see right here on the color bar. Always note the color bar with these meteorological maps. That changes to 8 knots. So we're kind of halfway in between those, so it's about 10 knots. Okay, so let's see what units we are expected to answer in. So the wind speed is measured in knots, so that's good. We can write that down. So we can say about 2 knots for A, and then about 10 knots for B. All right, let's get the wind direction. So I'm also using Plymouth State University again, but wind direction is a much harder thing to plot because the numbers can vary widely. So all that being said, we should basically take just a grid of various what are the wind directions at various places. Okay, so let's look at surface wind direction. And this is going to be in degrees. Now, by the way, the reference is like so. So the reference is north, east, and south, and west. This is 0 degrees. This is 90 degrees. This is 180 degrees. And 270 degrees. And winds are named for the direction from which they come. So a 0 degree wind would be coming from the north. And then an east wind would be about 90 degrees coming from the east. And so on and so forth. Okay, so let's try to get our cities as best we can. So again, let's look at that tip of the Sinai Peninsula and then come over here to find our point in Saudi Arabia. So it's going to be somewhere near here. Now, remember, we expected that the wind should roughly go from this direction. So 81 is coming this way. So that seems about reasonable. So let's say that it's somewhere between 81 and 77. So let's just say about 80 degrees. Okay, so let's go back. And let's say this is about 80 degrees. So it's going to be east. Let's see, east. It's definitely from the east, but it's going to be east-northeast. It's going to have just a slightly northerly component because it's going to be mostly from the east, but east-northeast. Let's do for Qatar. So we're about right here. So I see 200, that's hard to see. 231 degrees and 219 degrees. Okay, so that's approximately maybe 220 degrees if we take some sort of average. So 220 degrees is roughly from this direction. So it's kind of from the southwest. So let's see if that's what we expected when we go back to our image. So, and it turns out that that wind direction is going to be hard to get because essentially we have a pressure system, but we also have the sea breeze. So the sea breeze is going to strong off the Persian Gulf is really going to affect this. So let's just give an average value of about 220 degrees. And that's going to be mostly south. So it's going to be south and then from the west south. So southwest south. Okay. So I think we have number 3 finally taken care of. Let's look at number 4. We need the cloud cover in eighths. Now, I had to go to a different web page for this one. So the web page I found is weather.us. So this is the main URL. Now, it turns out they have archived images. You want to click like on satellite and then Europe, Africa, and you can see. Now, it turns out they only have about 1 image a day, but it's better than nothing. So this is a summary image for the day for these places. But notice that in northwestern Saudi Arabia, and probably this city is Doha in Qatar here, it looks like there's very little cloud cover. It turns out this over here would be cloud cover, or this, but it turns out we have almost exactly clear skies. So, I mean, there's very, very little cloud cover. Okay? Now, by the way, climatologically speaking, we expect this for the Arabian Peninsula because it's roughly desert. So I'm going to say this is about 0 out of 8. So 0 out of 8, and then 0 out of 8. Okay. So we expect the cloud cover to be very, very small. Okay? So clear. Okay. Let's now go to numbers 5 and 6. We need precipitation and we need temperature. Again, I used the Plymouth State weather maps for this. So let's go down to this one here. So this one is 6-hour surface precipitation. Now, part of the reason it's almost all purple is because it's almost 0 everywhere. Everything's less than 1/100th of an inch, which basically means no rain. So we're just going to assume that it's about 0. And again, this is what we expect climatologically speaking for the Arabian Peninsula. So we expect precipitation, we just want to say none, or just no, okay, or no precipitation. And then lastly, we need the temperature in degrees Celsius. Now the temperature in degrees Celsius is something that people really care about. So I have a contoured map over here, and I also have a numerical map over here. So on this contoured map, notice that the contours are every 4 degrees Celsius. So it looks like this reading is about 23.4 degrees Celsius, and this is just a little bit colder. So getting close to it. So it's right around, actually, 20 degrees Celsius, approximately right there. Now, how about here in Qatar? Well, notice here is a pretty large high temperature of 32.8. Here's 31.3. This is next to the Persian Gulf. It's probably going to be a little cooler. So I'm going to go with about 31 degrees Celsius. Okay? Again, approximately. Let's see if we can verify that over here. So this says 32. And then over here, this says 17, 17, and there's 20. So let's go ahead and update these. Let's maybe make this, we'll split the difference and say 19 degrees Celsius. And let's call this 31.5 degrees Celsius. Okay, so what we have here are the temperatures that I mentioned before. So the temperatures that I mentioned before, just quickly switch back, about 19 and 31.5. So what did we say? For A, we said about 19 degrees Celsius and about 31.5 degrees Celsius for B. All right, so this takes care of our first map. Let's do our second map. Now, our second map today is here in Europe. It looks like point A is located, it's really hard to see, but it's east of Denmark, near the Baltic Sea, so kind of northern Poland, if I've got that right. And then the second point is down here in the Atlantic Ocean, almost straight south of Greenland. Well, we need to, again, deal with these points. Now, again, we're trying to notice what kind of pressure systems are these dominated with. So for number one, I would say point A is definitely dominated by a low pressure system. You can see very large numbers of frontal systems. There's kind of this comma shape, which is classic in the Northern Hemisphere for low pressure. There's low pressure here not too far from point A. So we're going to say for point A, we're going to say low pressure. For point B, we're going to say that the low pressure is moving away, but the high pressure is coming towards. So 1020 millibars or 1020 hectopascals, that's going to be high pressure. That's relatively high pressure. Okay, so now let's get those numbers. It's hard to see, but we got to get those as close as we can. Look carefully on these diagrams. Here's a 1012 line. Here's 1008. This is 1002, so it's going to be a little bit more than 1002. Here I think I see 1008. So it's probably going to be 1010 or so. This is approximate. So for A, it's going to be about 1010 hectopascals. All right, for point B, it's about 1020. Let's move on to number 3. Let's first do wind speed, like we've done before. So again, using Plymouth State University, here I have wind speed. And again, we want locations approximately here and locations way down here. Now this is a little bit off the map, so we'll have to estimate. But notice that here we've got about 7.03 knots. So let's say about 7 knots. And then here, this is in the dark blue. So the dark blue's anywhere between 8 and 12. So let's just call it 10 knots. It's an approximate. So 7 knots, 10 knots. By the way, over the open ocean, wind speeds tend to be uninhibited by friction at the surface. So a steady 10 knots is not unusual. 7 knots and 10 knots. All right, now let's deal with the wind direction. So I'm going to change color here and then scroll down to wind direction. Same as before, we're using these grids. Notice that, what about the wind direction here in northern Poland? Well, it looks to be about somewhere between 221 and 252. Let's check the pressure systems to see if we can confirm that. The wind direction should be dominated by these fronts. So it should be mostly in this direction. So this direction is more so westerly because the front is pushing in. Let's see if that verifies with what we said before. So 221 degrees, yeah, that's from the southwest. And then 252 is also from the southwest, but a little bit more westerly. Again, let's kind of split the difference. Let's maybe say 235. So 235 degrees. Okay, so 235 degrees for point A. And that's going to be southwest. And then how about point B? Well, it's over the open ocean. Most of these out here are hard. It's hard to tell. We should use the pressure map to aid us. Okay. So the wind is going to be nearly geostrophic. In other words, very not much affected by friction. So in the northern hemisphere, when we stand with the wind at our back, low pressure's on our left, high pressure's on our right. So the wind direction should be roughly this way, approximately. Well, so that would be kind of from the north. And boy, these numbers don't really help us because these numbers seem to suggest that it's from the south. But again, that's well off the European continent. Okay, so I'm just going to go with this map and I'm going to say it's roughly from the north. So I'm going to say 350 degrees. So 350 degrees. And that's going to be north-northwest. So now we're on to number 4, which is the cloud cover. Again, this is just a summary of the day. Now notice, keep in mind, this is a summary of the day. Notice there's this comma shape over here over north-central Europe. We saw that there were fronts here on the real map. And remember, this is just one image for the whole day. It's probably actually taken middle of the day or something. Who knows? But I guess what I'm trying to get at is, even though there doesn't seem to be much cloud cover here, I'm assuming there is going to be cloud cover at some point during the day. So it's probably going to be this amount, and that's moving over. So let's go back to what we had before. And we see that at point A, we have a stationary front here. So it's probably close to 7/8, I'm going to guess. Probably about 7/8, because when this cloud cover moves over, it's going to be almost entirely cloud. So I'm going to say 7 out of 8. So I'm going to say mostly cloudy, okay? Now how about out here? Well, you're close to a high pressure system. We have to approximate, but there's probably going to be a few scattered clouds. So I'm going to say probably about 2 out of 8. So I'm going to say mostly sunny. All right, let's look at number 5. Now for number 5, we're talking about precipitation. Precipitation, rain, snow, hail, other. Turns out at point A, if we have a stationary front and this is the springtime, this is going to be rain. And we should be able to actually confirm that given the temperatures. So we'll look at temperatures here soon, but if we're at 18 degrees Celsius or so, I mean, that's probably going to be in the range of rain. We need below 0 degrees Celsius to be frozen precipitation. So we can say, fine, this is definitely going to be rain, okay? Now, how about point B? Again, point B is out over the open ocean. It's dominated by the high pressure. We're going to say no precipitation. Lastly, the temperature. So we already kind of alluded to that. So I believe it's here. So I'll put myself down here. So the temperature ranges from, let's see, negative 1.69 to 32.3 degrees Celsius on this contour chart. And we're looking somewhere around here. And again, it's kind of northern Poland. So it's somewhere around here. Okay, so we're talking, now this red contour starts between 18 and 20. Here this says 18. I'm going to say this is approximately 18 degrees Celsius. It's going to be hard. It turns out you can actually see where the warm front is, because you can see that it's warmer behind the front here to the south, and it's much colder north of the front. So the stationary front has just barely moved by, so it's just a little bit warmer than these cold temperatures of 10 degrees Celsius. So again, I'm going to say it's about 18 degrees Celsius. Again, here's that warm kind of stationary front. Okay, so about 18 degrees Celsius. Okay, so 18 degrees Celsius. And finally, how about over the open ocean here? Now, over the open ocean, it's hard to estimate. Okay? We're kind of in the central Atlantic. We should use the temperatures I saw on the west coast of Europe over here as a proxy. Okay, as a proxy. So going back to our temperature map, notice the west coast of Europe here is about 16, 15 degrees Celsius. Let's see if I can move this map out of the way to get more towards the ocean. So in terms of the central Atlantic, it looks like if you're in the tropical waters, it's about 20 degrees Celsius. If you're over here, it's about 17 degrees Celsius. So let's take an average. It's hard to tell. Our point is somewhere over here. So let's take about 18.5 degrees Celsius. That's approximate. It's hard to tell exactly, but we're just going to go with it. 18.5 degrees Celsius. Okay, so we now have all the weather variables for these cities. Keep in mind, we had to look at several web pages and we had to make some estimates and we had to try to confirm things. But hopefully this makes sense. Thank you very much for watching this video. Please smash that like button if you enjoy this content. Please subscribe to the channel to grow the channel. Please share this on your social media accounts, and I look forward to seeing you in the next video.